Hello everyone, today we are gonna learn how to use a distillation column to separate two different components. Let's say chemicals and then chemicals with English unit. Open selected template. First thing, set up and write in a title. Here I'm gonna use this one, n-hexane and n-decane. So unit, I'm gonna use metric units with bar, and then we should clarify the components. First thing, you can type here like n-hexane and n-decane. Okay, the other way you can find by clicking on find here, then for example let's say oxygen. You can see all kind of elements or molecules. For example, this is the oxygen, this is ozone, this is atomic oxygen, whatever. You can choose what you want. But I'm gonna use only these two things. If you see blue check marks here, it means you are in correct way. Let's say methods. This is common method. It is commonly used, but there's too many different methods as well. So this one I'm gonna use PSRK. When you go onto the method, you can see the whole name of it. For example, for this one, it's Peng-Robinson equation of state, but I'm gonna use this one. Parameters. So these are calculating automatically. Let's say simulation. First, I'm gonna use a pump here. So one stream as an input and one stream as an output. You can change the name of the streams. Let's say input here, and you can change the name of the unit as well. Let's say pump here. Okay, this is output. Let's say output then. So streams, you can see here pump needs some inputs, or you can go back and click on pump, like double click, then identify the pressure, let's say 5.2 bar, and efficiencies pump, let's say 0.85, and driver 0.96. So you can see the blue check marks right now. Okay, streams input. Okay, for input streams, we should determine the temperatures, pressures, let's say 70 Celsius and 1 bar. So total total flow rate should be maybe, let's say 1000 kilomole per hour. Okay, and mole fraction, let's say hexane 60% and n-decane 40%. It should be totally 1. Okay, this is also okay. And now I'm gonna use a column as a separator. I'm gonna use Redfrac because it's really rigorous. This is too big. You can make it small. Okay, when you double click, you can connect it into the column unit. Okay. Okay, let's say this is distillation. Okay, that's fine, distillate. I need two outputs here. Okay, what should I do? I should determine the inputs of the distillation unit. So this can be equilibrium, okay, or rate base. I'm gonna use equilibrium. So number of stages, let's say 15. This should be total. Okay, this kettle is fine. Phases is fine. Okay, let's make it boil up ratio. 4.3 is okay. And reflux ratio 6.1. And streams. So this is output as an input for distillation unit. So let's say 7. Above stage you can have also on stage vapor, liquid. The pressure is gonna be 5 bar, and these things are okay. I think everything looks good right now, so we can run it. Let's see what's going on. Okay, say result summary, streams. Okay, for S3 distillating. So mole flows. You can see all n-decane is in S4. So this is too small in S3. And here we separated some moles of n-hexane into S3 and into S4. So you can see the temperature of each streams and pressure values of each stream as well. So let's say, what is the temperature of this one? Results, temperature is 187. Let's make it cold. Okay, how we are gonna use heat exchanger, right? Oops. So delete this one. Okay, make it small a bit. This is input. So let's say heat exchanger, and one output needs for heat exchanger. Okay, let's make it 25 Celsius and 0 bar maybe. Okay, so let's run it, and let's find the S5 results. So temperature is 25 Celsius and the pressure is 5 bar. So my flows, you can see n-hexane and n-decane is the same with S4, right? Same, but the pressure is lower than before and the temperature is lower than before. So this is all for the first tutorial. Thank you for watching.